Now we're going to find the greatest common factor using factor trees, using prime factorization. So before we start, we need to know the difference between a prime and a composite number. I've noticed that this is something that we get confused about and sometimes we just forget. And so this is how I want you to remember it. A prime number is only divisible by 1 and itself. Okay, there's no other numbers that I can multiply to get to that number. So for example, the number 7. Take a second. Can you think of any two numbers that multiply together besides 1 and 7 that can make 7, right? No, we can't. 7's only divisible by 7 in itself. The only numbers you can multiply to get to 7 are 1 and 7. But if we think about the number 6, so this one's prime. I got this new cool pen. If we think about the number 6, it is what we call composite. So a composite number means that multiple numbers can go into 6 using multiplication. So we already know that 6 and 1 can go into it. Because every number is divisible by 1 in itself. But we can also get to this number by multiplying 3 times 2. So that makes that number composite. So when we do number trees, factor trees, you can see over here, what we do is we take the number. So if we're trying to find the greatest common factor of 12 and 56, what we do is we take the number 12 and we take the number 56 and we find the prime factors. So the numbers that nothing else can go into besides 1 in itself. What I mean by that is we're going to start out and talk about what two numbers can I multiply to get to 12. Well, you can see up here, and we hopefully know, we can do 2 and 6, right? 2 times 6 is 12, and it's important to remember that we're working with multiplication here. Well, I have 2. I can't do anything. I can't factor that anymore, so I can leave that there and move on to the 6. Now, I can get the 6 by doing 2 times 3. Now, I already know 2 is prime, is 3 prime. I think about it, yes, the only two numbers that go into 3 are 1 in itself. So my final factors are 2, 2, and 3, okay? Let's head on over to 56. Well, I know that 8 and 7 go into 56, and I know that 7 is prime. I can't multiply anything besides 7 and 1 to get to 7, so I'm finished with that 7. I could go ahead and circle it. And then I have 8. I know that 2 and 4 go into 8. I already know that 2 is prime, so I'm finished with that one. But I know that 4, I can factor 4 into 2 and 2 because 2 times 2 is 4. So now I'm at my final factors. We go back up here. 12, the prime factorization of 12 is 2 times 2 times 3. Let me write that down. And the prime factorization of 56 is 7. I can do 2 times 2 times 2 times 7. So make sure we remember all of those numbers. Okay, and this one's a little bit different than the ones you'll be dealing with. So I'm going to check and see which ones are the same. So I know that 2 and 2 are the same. And also this 2 and 2 are the same. Now there's no other ones that can match up, right? There's a 3 up here, but there's not a 3 down here. So since this one has two sets of numbers, even though they're the same number, it has two sets of numbers that are the same in the number tree. We have 2 and 2 and also 2 and 2. What we do here is we're actually going to, let me scroll down, we're going to multiply 2 by 2 since there's two sets, and we're going to get 4. So the prime factorization for these two numbers, 12 and 56, the greatest common factor is going to be 4. Now, when you move on to the next problem, you're only going to have one set of numbers that is the same. Okay, so if there's only one set of numbers that's the same, that is your greatest common factor. The only time you have to multiply them, like I did right here, is whenever you have two sets of the same factors. So you'll see what I'm talking about when you head to the next question. You'll only have one set of the same, and that will be your greatest common factor.